It's all you, Alex.
Great. Thank you, Gary, and thank you, Aaron, for coming. Yeah, the seminar series has been great so far, especially as Gary just said, as an employee. It's been really good for me to see kind of what's going on in the division and put names to faces. So I really appreciated it. So what I'm going to talk about here today is kind of a side project that I've been working on. So when I started working here at DMF, I was learning about how great of a kind of data source the Trawl survey was. And I was trying to think about ways how we could use this data to possibly try to improve some of the groundfish assessments. So again, this work is still, kind of preliminary and a work in progress, but I'd like to acknowledge kind of all the co-authors that have helped me with this so far, Sam, Matt, Bob, and Steve. So just a little bit of overview about what I'm going to discuss today. Pretty standard kind of presentation here. I have a little bit of introduction, so I thought I'd just set the stage so we're all on the same page. Kind of talking about stock assessment and indices of abundance. So how these indices are used in the stock assessment. And talk about some of obviously the methods and analysis that I'm doing kind of with the Trawl survey. I'm not going to get into any of the nitty gritty with this, but I'd be happy to answer questions at the end if people have them. I'm going to go over the results and then talk about, again, some of the preliminary conclusions and kind of next steps for this project and how I think it can help with future assessments. So just a little bit of background. I'm sure many of you are aware of this, but just in case. So kind of what is a stock assessment? So kind of on a 30,000 foot view level. So basically they're just mathematical models that are supposed to provide a simplified representation of a population and fishery dynamics, even though I know a lot of the time they don't seem overly simplified. But I really like this cartoon over here on the right that's from NOAA. That basically is just called the ABCs of stock assessment. So we have, and this is basically the data that's required for many of your conventional stock assessment models. So you have your abundance data, your relative abundance data, then you're going to have your biological data such as life history or growth estimates, and then you're also going to have your catch or population removals. So what I'm going to focus on here in this talk, and a lot of what my research is, what I'm interested in from a research perspective is really focusing on this abundance part and how we kind of include that into the assessment process. So to get relative abundance estimates to put into the assessment model, basically you can get them from two major different data sources. So the first one is fisheries independent, and then the other one is fisheries dependent. And then depending on which kind of data source you have available or you go with, it's gonna have some assumptions, and you're gonna kind of have to do some prep for it before you're gonna use it in the stock assessment. So the fisheries independent example would be the Trawl survey that we're going to talk about today in depth. And these are really great because they're designed to monitor abundance over time. And ideally what they're going to have is like representative samples throughout a stock's area or throughout a stock range. So you can see the example here, and this is for winter flounder, this plot down here in the bottom left from the Trawl survey. However, you can also use fisheries dependent data. However, using this to create a time series of abundance is typically more complicated because fishermen aren't collecting or reporting data with the purpose of creating an abundance time series. So typically this is done through CPUE or catch per unit effort standardization, which I'm sure many people have heard about. And basically what you do is you take this fisheries data and you're going to put it into kind of a modeling framework. And the point of this model is to remove the effect of variables other than relative abundance, creating a time series that reflects abundance. And I think this plot down here in the bottom right kind of does a really good job of showing why this is important. And this is from a Bentley paper that looked at kind of these model diagnostics, and we're actually going to be using some of them later in the talk. But you can see here, so your unstandardized or your raw catch rates, which would be just the number of fish caught divided by some effort metric, such as number of hooks in the water or soak time. You can see if we just use that in a non-modeling framework, we could see that we would think abundance has been increasing for this population. However, once we put it into that mathematical framework and we account for factors that might be influencing, why, where, or when we're catching fish, we can see that it actually shows a very different perception. So what's interesting here is that so this standardization method is actually also applied a lot of the times to fisheries independent surveys as well. And the reason for this is sometimes that if there's methodological changes that occur to the survey that need to be corrected for afterwards, or a lot of times they're actually applied to more localized surveys because the surveys don't actually have repetitive samples throughout an entire stock area. So this is very common down in the Southeast US where they use a lot of state surveys and they rely on these heavily in the stock assessment. And then additionally, you can also standardize. So obviously we have these really long survey time series that are great, but over the course of these years, a lot of the times environmental variables have changed or something else is occurring that you need to account for, which is where standardization could come into use. So I'm going to kind of get a little bit more into this as we go throughout the presentation. So those are kind of how the two different data sources you can use for an abundance time series. So how are they actually used in the stock assessment? And this is what I find really interesting. So these are two plots of actually both of the state trawl survey used in assessments in the region. So these are for Gulf of Maine cod on the left, and then from winter flounder for southern New England on the right. And this is both from the ASAP. These are diagnostic plots from the ASAP assessment models, which is, I think it stands for Age Structured Assessment Program out of the Science Center. But how you kind of look at these is the plots on the top left. So the circle values are the actual values that are coming from the trawl survey. So that's basically the way the Science Center does it is it's basically the number of fish per tow kind of in a given year. So these are the dots that you can see here for cod and the dots over here for winter flounder. And then what happens is the stock assessment model is actually fit to follow the trend of these survey data or of these indices of relative abundance. And then these examples here, the stock assessment is the solid line. So this is the stock assessment model fit for Gulf of Maine cod to the MADMF trawl survey. And over here, the same thing for winter flounder. And then the other plots you can see here, the other three are kind of diagnostics that we look at kind of when doing stock assessment to see whether or not these assessment models are fitting our indices well. So it's kind of a way to look at your stock assessment results. So that's a little bit of background, just kind of on indices of abundance and stock assessment. And now I'm going to kind of slightly transition into some of this work. So what's great is Matt gave an awesome seminar last week about the trawl survey, and kind of about the methodology and some of the things they catch. So I don't need to cover that in extreme depth, and I'm not going to. So a lot of this is going to build off of what Matt presented. But I think the main takeaways from the trawl survey here, again, is it's designed to sample, designed to create abundance time series. It's a really great long data set going back to the 1970s, and it operates twice a year, spring and fall. And then there's a lot of key information here that we can use that's important. And we're going to use in this analysis here, such as the number of fish caught, the weight of these fish, and then there's some environmental variables that are collected again for each of these tows, such as the depth and bottom temperature. And then here on the right, I'm sure many of you are familiar with this, but this is kind of the spatial map looking at the trawl survey and the different stratum that occur. And I would say the takeaway that just to remember from the slide as we move forward is try to remember these kind of regions, this numbering 1 to 5, because when they actually create abundance time series from this data for the stock assessments, they very rarely will use all of these regions. They'll do some subsetting here. And we'll kind of get into that moving forward. So for the trawl survey, again, this is what I'm really interested in. So this is going to be focusing on groundfish because that's primarily what I've been working on or what I work on. So this table here basically shows all of the stock assessments that the state trawl survey is used in as a time series of abundance. And you can see the species over here on the left. So cod, yellowtail, winter flounder, American place, and wolffish. So two things I should say before we dive kind of a little bit deeper here. So American place, the trawl survey was used in the stock assessment in the benchmark, but actually in the 2019 update, they ended up removing the MADMF trawl survey from the assessment model, basically because they thought that it was no longer a good index of the population. And they hypothesized that basically there's been some range shifts that could have occurred for American place. So basically the state survey isn't appropriate anymore to index them. But I think some of the results I'll show you here, kind of the methodology that I'm applying here might be able to help kind of reconcile some of these issues and maybe kind of get exploring using this index again in the assessment. And then also real fast here, so wolffish. I'm not going to go into wolffish today because there's actually a lot of zero toes in the data, which makes the analysis slightly more complicated. So I know how to do it. I just haven't had time yet. So this is something in the future I'm going to explore. But anyways, you can see the species, you can see the stocks. that are the trawl survey is used for. So for example, winter flounder is used for Southern New England and the Gulf of Maine. Then you can see here if it's using both the spring and fall time series or just one or vice versa. And then the method here basically shows, so in the time series or in the assessment model, is it using the number of fish caught or the weight of fish caught? So for most of the time series here, we're looking at kilograms or weight. And then again, this is what I was kind of talking about in the last slide, is that for the stock assessments from the Science Center for groundfish, a lot of them are only using certain regions of data. You know, so something to focus on. So this kind of gets me to kind of the questions and methods that I had for this. So one of the things I was interested in was I was kind of curious. I had this hypothesis that, you know, environmental changes have occurred in state waters. I think this is a fairly safe hypothesis to have, just based on all the literature that's kind of in the region, and I think a lot of common sense. So what I was curious about is, are environmental changes occurring in state waters, and then have there been shifts of fish possibly in response to these changes? So have fish shifted to different latitude? Have they been shifting farther north or south? Are they changing kind of their depth preference or habitat preference? And could this possibly be linked to bottom temperature? And then if these changes were occurring, I was wondering how this is affecting our perception of relative abundance. So, you know, are these fish moving within these different strata? Is this going to really affect our perception? So if so, I wanted to look at possibly standardizing or putting our trawl survey into a modeling framework to see if we can account for some of these changes and see if it's going to change our perception. So for a lot of the analysis, it's kind of just looking at general trends here, but there are some modeling that's done, and those are used generalized additive models. And the reason I chose this framework is because it has a really strong track history of both looking at being used for environmental analysis and CPUE standardization. And basically the reason for that is, at least for the environment, is basically it's like a linear model, except it allows for nonlinear trends between some of your covariates, which is good for the environment because we rarely see exactly linear trends. And then for this models, I followed, you know, standard procedures. So looking to see if any of the covariates were collinear, which was not the case, which I thought might've been occurring for bottom temperature and depth. And then also did typical model selection using AIC and deviance explained, and then look at some typical diagnostics looking at the residuals. And these two papers here on the right are actually really great. So this Pinsky paper is looking at climate velocity analysis, which I'll touch on here a bit. So you can actually model to see if the environment and fish are moving at the same rate or in different rates. And then this down here is this Bentley paper again about looking at standardization diagnostics. And we're actually going to be using some of the diagnostics from this paper to look at what happens when we start adding environmental covariates to our perception of abundance. So you're going to see several slides like this for the different species that I outlined in the table before. So I'm going to kind of walk you through them. So the first thing I should say is these plots here on the left, Sam helped me make. I think they turned out really well. But basically what this is it's kind of abundance by the different strata by decade. So in the top plot, it's average abundance over the decade. So the top plot is the 1980s. The plot to the right here is 1990s, 2000s, and 2010s. And then our darker red coloring here would indicate higher abundance. So what you can, or higher catch rate. So what you can kind of see here is this is kind of just a exploratory way of looking at, are we seeing any shifts possibly in the abundance of these species within state waters? And when I look at this, for some reason, my mind always goes to kind of north of the Cape or south of the Cape. And I think what's interesting here is you can see that for cod, at least, that their abundance was slightly higher north of the Cape in the 1980s. And that's kind of shifted away. And then now here in the 2010s, we're seeing abundance looks like it's higher south of the Cape than it was in the 1990s and 2000s. And then the plots on the right here are kind of looking at general trends. So on the y-axis here, you're going to have latitude, depth, and temperature, and this is by year. And so then the dot here is, there's one for each fall and spring survey, and each of these dots is going to be the weighted mean average for the year. So basically what that means is it's going to give more, the average for the year is going to give more weight to kind of the variable or the covariate that had a lot of higher number of cod in that year. So from this, again, these are just linear trends, but from this, looking at cod, you can kind of see it looks like cod might be moving slightly south, or we might be catching them south. In the survey, their depth also looks like it's been kind of decreasing here. So it looks like we're getting them at shallower depths. And then there's this slight temperature relationship here that is not temperature, that they might be catching them at warmer temperatures. And I should say these are significant. So the next one here is Yellowtail Flounder. So same plot again. And I think when looking at the spatial plot here for Yellowtail, it's more apparent kind of in these spatial shifts that could be occurring here by decade. So I think, really here, it looks like we're kind of not catching many Yellowtail here anymore, kind of south of the Cape. And you can see it kind of almost kind of dwindles down over the decades, starting at the 80s into the 2010s. Do the same thing here, looking at latitude, depth, and temperature. So here, it looks like there might be this northward kind of shift occurring in recent years. This shift towards deeper water as well. And then this temperature here, there's not really that much of a strong relationship, which I think is kind of interesting. The temperature doesn't seem to be changing that much at what we're catching Yellowtail. So now looking at winter flounder, the same thing again. Here, you can see that it looks like there's been fairly high abundance in the different decades, but it looks like we might be having slightly less abundance here south of the Cape in more recent years, which I think would agree with kind of the stock assessment from this area. For latitude, we can see this kind of this northward shift again for winter flounder, shifting to deeper depths as well, is what it looks like. And then temperature, there is this slight kind of linear relationship where it's getting slightly colder. And then American in place, for the last species, similar. So here you can see that the majority of American in place are caught kind of north of the Cape here. There were some south of the Cape in the 80s and 90s, but that's kind of gone away. And again, this is the species where the Trawl survey is no longer used in assessment as a time series of abundance. But from the latitude here, you can see there's a shift, northward shift in latitude, deeper depths, and a kind of a constant temperature here as well. So on that first thing, that first question I had is, are environmental, shifts possibly occurring in state waters? And I think from just looking kind of at the raw data, which is what that is, that does appear to be the case. So you can see, to me, kind of what the preliminary takeaways here are. So I think it's really interesting here that for cod, it looks like they're moving possibly south into shallower depths. And I was talking to Matt, Bob, Steve, and Sam about this, and there's some hypothesis that maybe they could be moving to preferred habitat, or there might be some change in size structure that we're catching in the Trawl survey. So I think this is something to look into further, and I'd love to kind of get other people's feedback on why this might be occurring. And then for the flounders here in place, we're kind of getting the shift further north and to deeper waters, which I think to me makes more sense conceptually, just kind of with the other literature in the region. And then these plots on the right are kind of some more preliminary analysis looking at climate velocity. So on the Y, so the top one's latitude and the bottom one's depth. So on the Y-axis, you have taxon shift. So, and this is meters a year. So the kind of where the center of these species are. And then on the x-axis, you have thermal envelope shift, so how fast the environment's moving in meters a year. And basically, the way to read this is if the species are above this 0 to 0 or black line, they are moving faster than the environment, and vice versa. So here, again, this is preliminary, but it looks like American place and Yellowtail might be moving faster than the environment than Atlantic cod and winter flounder. So back to this table again. So that kind of answered the first question, like I just said. So the next question I had is, how can we try to incorporate some of this information into how we're actually calculating our time series of abundance and how they go into the stock assessment. So you're going to see now a lot of plots like this. So this is kind of that next step now, looking at kind of this modeling framework. So the stock and the species here. So this is for cod, the Gulf of Maine. And then you're going to see this information provided. So the indices, that number, so there's 3, which means, so in the stock assessment for Gulf of Maine cod, they're currently using 3 indices of abundance. So they're using the Trawl survey from the state and 2 other ones. Here you can see the years that they're using of the Trawl survey from DMF. So they're using the entire time series. And then the regions, again, that map. So I'm pretty sure these regions are kind of north of the Cape and east of the Cape. And then the numbers here, so that's the unit, they're basically using the stock assessment. So they're using the number of fish caught per tow. And again, when they use them, so the survey is already designed basically to try to track abundance. So there's no modeling that's being done before they're used in the stock assessment. And then from the model development that I did, which is just some basic exploration that's going to need some more work here, these are the factors that were incorporated in it. And then this plot on the right here shows the index of what it currently looks like and how it's used in the stock assessment. And you can kind of ignore the values on the y-axis here because we're really just interested in the rate of change. So now you're going to see a fair amount of plots like this. So this is kind of a diagnostic tool when we put it into a model framework to look at, kind of what influence that would be having on our abundance time series. So what you're going to see here in the top right, there's going to be this term, which is here year, which basically means this is what happens when we just add a year effect and put it into the model framework. So the black line here is our original index, which is our raw data. And then once we put it into this is a basic model with just year and an error distribution. This is what the model kind of plots out as the time series of abundance. So you can see, and I should say, ideally what you should want, or what I think we're trying to get at here is when we're just putting in a modeling framework, you should really be getting a very similar trend that we're seeing. And then when we start adding other covariates, it should start to deviate. So there is some more work that needs to be done here. But from putting into a modeling framework here, you can see there's more variability earlier in the time series for cod. It kind of pushes down some of these peak years of abundance, which initially gave me a lot of kind of heartburn. And I was really concerned about why we're seeing this. But when I actually looked into the raw data, these years are driven a lot by really large tows. There's very few tows that catch a lot of fish that are really driving these years up. And then you can also see the modeling framework kind of pushes it further down here a little bit after 2010. So that, and then we can also now look at what happens when we add another term to our modeling framework, which is what I'm pretty much interested in, is kind of how these environmental variables might be influencing our perception of abundance. So this purple line now shows the model that has year, and now depth is also added to it. So you can see what happens when we add depth and how it shifts the trend. So it actually shifts this period down slightly more around 2010, does shift this year up, this one peak year up here as well. And then finally, for this model, the last thing that was selected through model selection was temperature. And you can see what happens when we add temperature to the model as well. So it actually shifts this further down a little bit as well. But there does appear to be kind of this increase in recent years. So even if our model is not matching our raw catch rates exactly perfectly, we can still see by just comparing the model to itself what happens when we start including environmental variables. So even if we compare this blue line to our red line, we can still see that the model is estimating when we're including depth and water temperature, it is causing some shifts here, slightly downward around 2010. However, it does appear, the model does seem to think or estimate that relative abundance is kind of ticking up here in more recent years. So that's kind of what it looked like from cod. And now, so I'm going to kind of go through it for those other stocks that I showed you in that table as well previously. So this is for Yellowtail Flounder, so from Cape Cod and the Gulf of Maine. So from this assessment, you can see they're actually using more indices of abundance. So they're using a total of 6. So the Trawl survey plus others. And then here they're actually using less data. So they're starting in 1985, and that's because I believe that's when the stock assessment occurs. So we're using regions 3 to 5 here as well. And then kilograms are the units. So again, here you can see the 2 models that were selected from model selection, and this is the springtime series and the fall time series that's currently used in the stock assessment. So again, these are the raw trends. So here you can see when we add the modeling framework, it does a kind of better job than cod for spring, at least. It does a fairly good job. It's within the confidence intervals and does a fairly good job of tracking kind of that raw catch rate. You can see something weird is happening here in 1991 where it's really pushing it down. So this needs further explanation because I actually saw this for the same year in another species. So we'll touch on that in a bit. And then for fall here, again, the modeling framework does a pretty good job of following the trend. It does kind of lower some of these higher abundance estimates in more recent years. Do the same thing now, adding depth. So for the spring, the depth, when you incorporate depth, it kind of pushes this trend down slightly further. So it basically just kind of makes it almost fairly noisy So it kind of shifts the scale downwards. For the fall, it kind of adds some more variability here in the earlier years in the 1990s, but it does kind of push this one abundance estimate back up towards closer to our raw kind of catch rates here in recent time. And then water temperature was only selected for the fall model, not the spring, based on your standard model selection procedure. And you can see here it doesn't do that much, that much different. So it's kind of still following this variability or interannual variability. So I think my takeaway here from Yellowtail kind of is that putting in a model framework doesn't really kind of resolve. It follows the raw catch rates and doesn't do that much so far, at least. So the next stock is winter flounder for southern New England. Again, this stock assessment is using even more indices of abundance. So it's using 8. And I should have said, I guess, back in the introduction, you can use a combination of fisheries dependent and independent indices. And then within the assessment, not all these indices have the same amount of weight. So you can give certain indices that you think might be more reliable, higher weight, or have the model fit them closer than other ones. So not all indices are created equal. But here you can see we're using numbers, and then the trend here for winter flounder, again, it looks like it's been slightly decreasing kind of over the time period with some interannual variability. So winter flounder, again, when we put it into the model framework, so this is a little concerning, I would say. And again, this work is preliminary, so I think there's some ways I'm going to talk about it moving forward that we can kind of get at some of these issues that we're seeing here. But the modeling framework does a fairly good job of kind of tracking the raw catch rate trend at the beginning of the time series, but then you can see something funky is really going on here recently with a lot of variability and interannual variability that I think is definitely problematic and needs to kind of be further explored to see if we can get this red trend kind of more close to this raw catch rate trend. So then for winter flounder, when we add depth to the model, you can see adding depth actually pushes the model results even further down. So it estimates the time series is even, I would say, more kind of negative or even more decreasing. Again, even though there's a lot of interannual variability here in recent years, we can still just compare the model result to itself, and we can see incorporating depth, the model thinks that abundance has actually been decreasing kind of almost at this faster rate. Do the same thing with water temperature. So now adding water temperature. And again, the blue model now has year, depth, and water temperature in it. So this is like kind of a stacking effect. And you can see here that actually adding water temperature doesn't deviate it that much from when depth is included. But the combination of the two is definitely kind of driving down our abundance estimate in recent years. So the next one is Gulf of Maine winter flounder. So these regions, so 6 indices are used in the stock assessment. Again, it's using both the spring and fall. So here we're using regions 4 and 5, which are north of the Cape, and we're looking at kilograms. And you can see the trends that are currently used in the assessment over here on the right. So this does a pretty good job. The modeling framework here, I think, does maybe possibly the best job of kind of tracking the raw catch rate trend, which I think is promising. You can see, so again, the modeling trend here is in red and our normal raw catch rate is in black. You can see again here in 1991 for the spring, there's kind of this funky thing occurring where the model really wants to drive this estimate down. So I think this needs some further exploration. But for the fall, it does a pretty good job. There's a kind of a lower peak here in the late 80s, but it does a pretty good job of tracking it. So day of the year was actually, I explored including day of the year in these models just because it changes throughout the survey. You're not always fishing on the same day of the year. And I think depending when they go out might have slightly changed over the years. So there's some variability here. And it was actually selected in the spring model as being important. But you can see here when you add day of the year to the model, it kind of increases some of that interannual variability for some of these years. Depth, so depth was important for both of the spring and fall survey for this model development. Here for the spring, again, it kind of pushes the time series up a little bit, still with that interannual variability. Depth here for the fall, it doesn't really do that much. It's kind of similar trends throughout. Spring, temperature. When we include temperature, it actually pushes the spring estimates kind of closer back towards that raw catch rate. And then for the fall, again, adding water temperature changes a little bit in here. There are some differences, interannual differences. And there's kind of this big one here in the late 1980s. But I would say overall, putting these two time series for this species into a modeling framework really doesn't change our overall perception of relative abundance that significantly. The trends are kind of still there, which I think is a good thing. So then the last species I'll get to here, again, is American place. And again, this time series is no longer used in the assessment, but these were the time series used in the benchmark. And again, just to highlight this, so they stopped using this American place catch rates from the Trawl survey because there's kind of the shift of spatial distribution change and basically them not being in state waters anymore. Or at least enough to index the population, I should say. So this is for the Gulf of Maine. So again, regions here are 3 or 5, so north of the Cape, and you can see the modeling frameworks down here as well. So when we put it into a model framework, again, which is the red line, so where this is adding an error distribution and adding the year effect, you can see it does a fairly good job of tracking the raw catch rates over time. So the red and black lines are fairly similar. There are some discrepancies and variation here in recent years, both for the spring and fall survey. So I think this needs to definitely be explored further. And I wonder kind of why this is occurring in the more recent years, especially when we look back to one of those winter flounder examples too, there's a lot of variation here. So this is something that needs to kind of be explored further. And then when you add depth in for the spring time series, it really doesn't do that much. There's some variation here, but I would say the overall trend is very similar. For the fall, however, I think when you start adding depth in, it kind of pushes some of these higher abundance years in the early 90s kind of down a little bit. However, there's still this variation towards the end of the time series. And then water temperature was only important for the spring based on normal model selection. But again, here there's a lot of noise going on here, but I don't think including these environmental variables really gives us a crazy different perception of relative abundance. So these are preliminary conclusions again. So this work is still ongoing. I think there's a lot of ways I can refine it and kind of make it better. So for these species, so I would say some of the takeaways so far from cod, I think putting into the model framework kind of reduces some of these peaks in abundance, which originally gave me heartburn, but I think those might be due to some larger tow values that the model's kind of almost treating as outliers. And also, so one of the ways you can analyze time series of abundance is if there's any kind of peaks, kind of interannual variability changes that aren't realistic for the biology of the fish, because this is supposed to track their abundance through time. So if we start seeing these crazy increases and decreases that aren't realistic, there's some issues with the index. So I think kind of incorporating into this modeling framework might help us deal with some of these peaks and valleys that we're seeing. From Yellowtail, it really didn't do that much putting it into this framework. We're still getting very similar trends, some different deviations, but incorporating the environment really didn't change that much. For Yellowtail, for winter flounder here, for southern New England, there are these issues later years in the model, but I do think this needs to be explored further because when we start including water temperature and depth, we're kind of getting this more decreasing trend. So this should be kind of explored. For the Gulf of Maine, there were similar trends for winter flounder, and then American place. Again, it's currently not being used in the assessment, but I think as this work goes forward, we might be able to actually get at are these kind of range shifts occurring, and we might be able to kind of reconcile some of these differences possibly to see if we can get the time series included in the assessment again. So again, takeaways and next steps, just trying to tie this all together because I know it's kind of a lot of information I've thrown at you. So again, the two questions I really had is like, have environmental changes occurred or have shifts occurred in species in the Trawl survey, specifically groundfish? And I think from just looking at the raw data that I showed you at the beginning, it is, I think this makes sense because it agrees a lot with a lot of the other literature that we're seeing in the region. And I think what's interesting here, so for cod, again, it looks like we're catching them further south and in shallower habitat, shallower depths than we have in the past. And again, there's some thought this might be due to habitat preferences or changes in size, but this is something I'd like to explore further and love some feedback on. And then for our flounders in American place, they're kind of shifting north and deeper, which is what a lot of the literature shows for fish in the region. I think a takeaway here is that putting it into a modeling framework, so the Trawl survey results, is definitely altering trends. I think further work needs to be done on it to fully understand it. And I'm not saying that putting into the model is a better results, but I definitely think it's at least a diagnostic tool or something that should be done to look at the influence of possible covariates or changes in the survey over time. So I think it's an important, at least exploration that we should be doing before we start for time series that are going into stock assessment. So again, this work, next steps, one of the things I would like to do is look at some of the other species. So I still need to do wolffish, again, which is another groundfish. So I'm going to do that. Another major thing that needs to be explored is looking at interaction terms. So basically what that means is we saw from those plots in the beginning, there are these trends with depth and water temperature changing over time. So you can account for that in the modeling framework by putting interactions in between these covariates. But when you start doing that, it makes it harder to estimate relative abundance. There's more math that you have to do basically to get those year effects out. So that needs to be explored. Another thing that I think would be interesting is looking at satellite data and comparing it to the Trawl survey. So we could add another more environmental covariates in to see if other ones might be driving changes, such as chlorophyll, sea level pressure, wind, basically anything there's satellite data for, which I think would be very cool. And then finally, I think the real next step that would be interesting is kind of combining all this work together is looking at it in a spatial temporal modeling framework, such as VAST, which is basically a model developed by Jim Thorson out on the West Coast for standardizing trawl survey data. And what's really cool about it is you can actually separate out covariates that you think are influencing catchability versus density, which is nifty. And what's really nice about this modeling framework is it allows for changes in space and time. And the same model can calculate an index of abundance. It can calculate range shifts and effective area. So I think this is something to be worth exploring going forward. So finally, I'd just like to thank basically all the DMF staff and volunteers that have kind of participated on this survey throughout its history. Again, there's a relatively new employee. It's an awesome data set to work with, and I'm really looking forward to hopefully getting out there and helping with the survey in the future. And then I'd also like to thank Vinny and Mark, who helped send me a bunch of this data and walk me through it. And with that, I'd be happy to take any questions.
Thanks, Alex. Hold on, let me stop.